Hello, hello dear pupils. Welcome to our tutorial videos. And in this video, we are going to be dealing or solving a question on simple machines. The subject is physics. Okay, so now the question is saying a load is to be moved using a wheelbarrow. Given that the mass of both the load and the wheelbarrow is 25 kg, calculate the efficiency of the wheelbarrow. Okay, so the wheelbarrow here is the simple machine that we are talking about, and this type of a simple machine is a lever machine. Okay, so now since it is a lever machine, we need to remember that under lever machines, you need to know or understand the principle of moments. So you'll find that at some point we're going to apply the principles of moments. Okay, so now the question is saying a load is moved using a wheelbarrow. Given that the mass of both the load and the wheelbarrow is 25 kg, calculate the efficiency of the wheelbarrow. Okay, now, to calculate efficiency, you need to know the formula for efficiency. And the formula for efficiency is given by the formula. So efficiency of a machine is given by the formula mechanical advantage over velocity ratio times 100%. That is one of the formulas. Another formula that you can use to calculate efficiency is energy output. Okay, so energy output over energy input times 100%. Okay, apart from energy output or energy input, you can use power output, power input. You can also use work output over work input. Okay, so all those formulas can be used to calculate the efficiency. But in order for us to calculate the efficiency for this question that we have, we will observe that we can only use the formula for mechanical advantage over velocity ratio times 100% because according to the diagram, what we've been given can be used to calculate mechanical advantage and the velocity ratio. But before we do that, what do we have? So we've been given 25 kg, which is the mass of both the load and the wheelbarrow. Okay, so how are we going to use that? Now, mechanical advantage is given by the formula. So mechanical advantage is given by the formula load over effort. Okay, so load over effort. So for us to calculate mechanical advantage, we are going to use the formula for load over effort, where the load is the mass of both the wheelbarrow and what we are lifting, the load, multiplied by 10 newtons per kg, because that's the gravitational field strength. Okay, so load will be calculated using, so load is going to be, load is equal to the mass of the wheelbarrow and the load is 25 kg times 10 newtons per kg, which is going to give us 250 newtons. Okay, that is the load. Then the effort is here. Okay, so the effort will be calculated here because that is where the wheelbarrow is lifted. Okay, so since there's no any figure here, meaning we have to calculate the effort. But to calculate this effort, we are going to use the principles of moments. Like I earlier said, to deal with lever simple machines, you need to at least have an understanding of principles of moments. Okay, so to calculate F, which is the effort, we are going to use the principles of moments. So it being a lever machine, the wheel is our pivot. So the pivot is at this point. Okay, the force one or load one will be the load of both the wheelbarrow and this load inside the wheelbarrow, and that load or that weight was we calculated it to be 250. Okay, so it was 250 newtons. Okay, so at that point it is 250 newtons. Then the force at this point is the one that we want. Okay, and the pivot is here. So according to the principles of moment, the sum of the clockwise moments must be equal to the sum of the anti-clockwise moment in order for the system to balance. So we are therefore going to say, so coming here, we are going to say uh, force 1, okay, using the principles of moment, we'll say force 1 times distance 1 is equal to force 2 times the distance 2, or you can say weight 1 times distance 1 is equal to weight 2 times distance 2. So weight 1 or force 1 will be the force of the wheelbarrow or the weight of the wheelbarrow and this load, which is 250 newtons, and the distance of this weight from the pivot is 70 centimeters. Okay, so we are therefore going to say 70 I mean force 1 is 250, so 250 times 70 is equal to force 2, that is this force or the effort that we are looking for. Its distance from the pivot is 70 plus 50, which is 120 centimeters. So we are therefore going to say force 2 or F times its distance from the pivot. We said it's 120 because you add both 70 centimeters and 50 centimeters because that is where our force is. Okay, so now finishing this, we are therefore going to say 250. Okay, so we'll say 250 times 70 using the calculator. We'll say 250 times 70. We are therefore going to have 7,500. Okay, is equal to F times 120. This is going to give us 120 F. Then we divide by 120. We divide this side also by 120. And the value of the force that was used is going to be this to that. So 1750 divided by 12. So let's use the calculator. So using the calculator, we'll say 1750 divided by 12. So the answer is giving us 145.80 newtons, meaning this was the effort that was used in lifting this wheelbarrow and the load. Okay, so therefore, going back to our initial plan, remember, is to find the mechanical advantage. So the load is, okay, so going to our initial plan, we have mechanical advantage is load over effort, and our load is 250, our effort is 145.8. So let us calculate the mechanical advantage. So therefore, MA is going to be, the load is 250 over the effort. The effort is 145.8. Then dividing that into that, mechanical advantage is going to be 145 divided by 250 divided by 145. So 250, okay, so 250 divided by 145.8. The answer is giving us 1.7. Okay, so the answer is 1.7. Mechanical advantage is a ratio, and so it shouldn't have any units. That is our mechanical advantage. Okay, so coming back to our initial plan is to find the efficiency. That is the question we've been asked. So we've found the mechanical advantage. Next is we find the velocity ratio. So we're therefore going to say velocity ratio. So velocity ratio, VR, is given by distance moved by the effort over distance moved by the load. Under the principles of moments, we are going to say the distance of the effort from the pivot over the distance of the load from the pivot. So coming to our diagram, the effort is at this point. Its distance from the pivot is 70 plus 50, which is going to give us 120. That is the distance moved by the effort. And so we are going to say velocity ratio, distance moved by the effort is 120 over distance moved by the load is going to be 70 centimeters. So we are therefore going to say 70 centimeters. Okay, when we divide 120 divided by 70, we are going to say 120 divided by 70. The answer is giving us 1.7. Okay, so the answer, the velocity ratio is giving us 1.7. Therefore, going back to our efficiency, so efficiency is therefore going to be mechanical advantage. We found the mechanical advantage to be 1.7. The velocity ratio is also 1.7. So mechanical efficiency is therefore going to be 1.7 over 1.7 times 100. The answer is going to be, this divided by that is 1. 1 times 100 is 100%. Meaning that this machine was an ideal machine because its efficiency is 100%. Okay, so efficiency is 100%, meaning that the machine is an ideal machine. That is, if you are asked to state what type of a machine it is. But usually, the efficiency is always, and most of the times, the efficiency is always less than 100% because some of the effort is used in overcoming friction. Okay, so watch the video as many times as you can, follow the stages, follow the formulas and how they've been applied, and try some more other different questions, and follow our Facebook page and also our YouTube channel for more of such educative and very important videos. Thanks very much and stay